graciously has provided the venue and will be providing the food. And I think we are going to get a tour of your facility a little later, which will be coordinated by Christy White. And so, Christy White, thank you for setting everything up.
Yeah, you're welcome. Thanks for coming.
So this is really mostly today about IoT design, which I think is something that's not touched on very much, at least not in presentation. So we often talk about security and electronics and mechanics and data processing, transmission and protocols and such, but rarely do you hear a presentation on this. And I think it's very important, right? Why? Because in order for devices to be marketable, they've got to be attractive to humans. So that's what this is all about. Yes. Well, we have Barry Hutzel from Baza Design and Greg Austic from MSU. They've been collaborating on an interesting project that they'll describe. And then after pizza, which I think will occur at 7, we'll be having Dan Bayer and Greg Nowak of Modustri present on other projects that focus on design. With that, is there anything I've omitted?
No, I think so. I think we got a couple.
Okay, so please take a moment to introduce yourselves more thoroughly, your companies, and then teach us.
Okay, awesome. Well, thank you for having us, for Greg and I, for this event. When I presented the idea to Elliot, it was kind of like, I think this fits, and I'm kind of curious whether or not it'd be something you guys would be interested in. And he jumped all over it because it's like, oh, I'm not sure I'm ready for the 24th, but we'll see what we can do, kind of thing. So, talked with Greg, and Greg and I, agreed that we could possibly do this. And so, thank you for all coming out on a Wednesday night here and listening to us, because I don't normally do this kind of thing. I don't usually volunteer to do something like this, but I thought it kind of made sense in what Greg and Matt were looking for. And thank you guys, for bringing us in for this kind of thing. And again, thanks to Modustri for hosting us. This is awesome. So thank you very much. So anyway, multi-spec and photosync as a umbrella. You can obviously jump in any time and say you're wrong, Barry. But multi-spec is this handheld device. It is a product that works with plants to read the plant's health, and then you can translate that information up to wherever as it relates to a umbrella of connections. So worldwide, and through Michigan State and their biology department, we collaborated on this product, and so it's kind of cool that we got this opportunity. And we see this the photosync umbrella of discussion here in 3 acts. So first act will be Greg talking about the background of this and where they came from. Second act will be me talking about how I came in and collaborated with Greg and his staff. And then the third act, he kills me off and starts the third act with a where are we now kind of thing. So anyway, having said that, first I'd like to talk a little bit about us. I'm going to talk about me a bit and then turn it over to Greg. So, came from Cincinnati. Went to the University of Cincinnati as an industrial design student, 5-year degree. Actually, let's step back first to the beginning. 1960, I was born, and I was a child of the 60s, and drawing race cars and dragsters with 3 engines attached to it, that kind of stuff. My mom, God rest her soul, promoted my artistic side and really made me believe I was actually good at what I was doing. So, even though it probably was crap, stick figure stuff, she really, brought me along when it came to the interest in creative illustration art and promoted me through. So, 70s, went from dragsters to drawing full-scale images of Kiss and Ted Nugent, and when Ted Nugent was cool, and some of the other, I was a rock guy, and so that was kind of, where I was. Made my way to the 80s, started going to school at Cincinnati, and went from rock to punk rock, right? Or new wave, and my vistas grew, in terms of who I was. I mean, design school just opened me up, and it kind of led me to where I am right now, where I am today. So after school was over, got a job at Hovey Bicycle, and worked there for over a year. Bicycle components, and their exhibit work, to the point where I was actually designing the exhibit, building the exhibit, and then taking it to Toy Fair in New York and getting it installed as part of what I was supposed to be doing. So it was kind of fun stuff. Right after that, I got an opportunity to move to Holland, Michigan, and work for Donnelly Corporation. 18 and a half years there as part of their industrial design staff, managing the studio, the model makers, the industrial designers, the brand management. I was doing more exhibit work there too, in fact. So it was kind of this range of things, but a lot of automotive parts and pieces and product. After 18 and a half years, they kicked me out, most of the team. There's only probably one, well, Daryl, you're the only one that survived that whole fiasco. But anyway, point is, sorry, Daryl. So anyway, then got almost immediately an opportunity to work at Tiger Studio, and that's where I got to start working in a variety of areas bigger than automotive. So, Hutzel, what do we got behind me? Oh yeah, Tierra Yachts and Forcia and lighting and furniture. So that kind of led to this, and where I am right now as being Baza Design. And I've been Baza Design myself for over 7, well, nearly 7 years. And all those experiences and all the people I met along the way are now my clients. So number one rule, don't burn a bridge. If you can help it, don't burn a bridge. Because most of my clients, in fact, probably in every one of these, from Amway to Qualite to Cascade, DCN, every one of those is either a person I worked with directly or worked alongside or worked for me at the previous employments. So very exciting stuff, and the range that I get involved in too is kind of fun. Omega Medical and DCN, and for that matter, Headtronic, are handheld stuff, and so that led me perfectly to being able to help Greg with his thing and what we were going to get ourselves into. So at this point, I'm going to turn it over to Greg. He can talk a little bit about himself. Obviously, he was very stingy in not giving me any images to put in, so I just threw some stuff in for him to talk to or talk about himself, and then we can get into the background. So,
yep.
You tell me when to hit the button.
Okay. Yeah, I'm Greg. I have a long storied history, which I won't bore you with, because I really want to talk about photosync. We started this project about 4 years ago. Go ahead.
Act 1.
Yeah.
Here we go. Project background.
So we started this project about 4 years ago, and I was in East Lansing at a board game conference, making board games. That's what I was doing. And I saw this guy, Dave Kramer, who's a professor at MSU, who studies photosynthesis, and I was like, I'm interested in photosynthesis, so I sent him an email. Say, hey, can I come talk to you? He said, sure. So we sat down, and he told me a story about like 8 or 10 years before, he met some professor in Africa who studied plants and wanted to measure photosynthesis. And except that to buy a device to do so would cost the equivalent of a year's salary of every single person in his department. So Dave thought that seemed unreasonable. He's been developing devices to measure photosynthesis for 20 plus years. That's sort of what he spent his life doing, and then doing the science on those devices. So that was Dave's perspective. I came in with some experience developing technology in the biodiesel industry, and then getting very frustrated with science in a very closed world. So I became an open technology advocate, and was trying to open up science in a way that I think is now happening. So we kind of combine those things, and that's what photosync is. It's a democratization of science, open source approach applied to agriculture and getting information on plants. So we proceeded then to take this little shell of an idea to people like Robert, who's an amazing hardware engineer, Sebastian, who's a biologist turned a software developer. It's very strange. And then a Ruby developer, Pro, who has a startup called Venture. That core team of 5 folks did most of the work that you'll see. So the goal of PhotoSync really is to create, share, and analyze plant health data. And I'm going to show you the structure here in a minute. Basically, it's a device which I failed to bring, which you have some pictures of. I think Barry has one.
Yes.
Sorry. Which measures plants in the field, measures photosynthesis, chlorophyll content, leaf temperature, a whole bunch of other stuff, and then communicates that up into the cloud so that people can share it and analyze it. But really, that's like what we do. But what we're trying to implement is to enable people to both ask and answer difficult global scientific questions. And when I say people, I don't just mean scientists. I mean anybody, right? I mean a 15-year-old or an 80-year-old. I don't care. So the point is to democratize the scientific process, to bring quality to the top, not by a stature, but by impact. And to not just do that, there's a lot of people out there sort of in this space who are doing that, who are attempting to do that, but they're not putting in the scientific rigor into the equipment or into the process to output valid results. And that's where the difficulty comes in. And I'm not going to use specific examples, but it's not easy to collaborate on a mass scale and output scientific quality stuff. It's just not. And that's where the design pieces come in. And Barry's going to talk about the physical parts, but there's so many design pieces creating a platform such that any person can collect data and that data can be used for scientific outputs, meaningful scientific outputs. That requires a lot of stuff. So that's what we're trying to do. So what do? We are building a sandbox. That's what this platform is, right? I'm not trying to answer those questions. I'm trying to get other people to answer those questions, right? I'm not playing in the sandbox. I'm providing the tools, a nice space, some shovels, maybe a giant tire, right? So I'm trying to make the space so that if I want you all to collect data as a part of a project that I'm doing, like maybe I'm trying to say, what's the range of photosynthesis in the environment, right? And I gave you all a device, and I gave you all directions. And I said, go out and collect data, and you're all excited about it. How can I ensure that the data that you collect is good? How can I ensure that the people who continue to collect data are collecting good data? Like, you're the ones who I want to continue to support and to interact with. When there is bad data, how can I make sure I find it and get rid of it and flag it? Or, even better, how can I teach you in process, without tutorial videos and reading crap, to identify bad data, right? Then, instead of just me building a bunch of knowledge, I'm building all of our knowledge, and that's a big plus. So there's a lot to building that sandbox, and that's what we want to focus on. So that's like the theoretical garbage. So what is it for real? That's what you guys want to know, because you're hardware and software people. Go. This is what it is, right? So we have this nice device, which Barry designed, measures photosynthesis and a bunch of other stuff. Via Bluetooth or USB serial, connects to a desktop app, which is currently built as a Chrome app, which, if you know, is now, Chrome apps are now going away. So it will be built in Electron. But anyway, it's JavaScript and it's fine. And then there's an Android app, which hopefully Google doesn't get rid of Android. So anyway, communicates with those things, Bluetooth, USB. That provides the feedback to the user, like they take the measurement and they're like, okay, this is good or this is bad. It provides them warnings if it's bad. It allows them to collect data as part of a specific project or answering a specific question, that sort of stuff. And then the data goes back to the website, which is built in Ruby as a database. And then they can analyze their data there, they can share their data, they can try to make conclusions and output those conclusions. And eventually they'll be able to use some pretty neat statistical and other modeling tools to do predictions. That's sort of the long-term goal, is to enable individuals to do predictions. There's kind of a perspective in the space, and I think you'll see a lot of companies do this. Like their thing would look exactly like this, except at the top would be the company's brain predictive model then going and selling their stuff to everybody. Right? Like I'm sure you've seen that model, which is totally legit, I get it. But we're kind of doing the opposite of that. We're trying to get that in the world, and we're letting the users create the brains and the predictive models to then feed back to each other. So we started at MSU. We built out of this lab. We very, very intentionally did it in an open way. And as a result, we didn't have any issues with tech transfer. So we were able to sort of spin out in a non-traditional fashion. We're still in the process of doing that. But the things that we've learned along the way is, this is probably true in any software. I'm not really a developer, I just became one. You can't, if you're building a feature, you have to connect every single dot. If you make a feature that's 95% of the way done in a platform, it's not like 95% of users will then use it. 0% of users use it, right? Like you have to make, it has to be 100% done. We just, over and over and over again, we saw that. We make things that were very, very close, but we were just missing one tiny component. That didn't work. This is a good example of a feature that we created where this was much closer. We tried to implement this. So, go ahead. This was pretty obvious. You were thinking ahead. Don't do that. We did that. It was a learning experience, but it was a waste of time. I think. So some of our original friends were based on doing work in Africa, and so it was really important that we did work there, and I'm glad that we did, but we shouldn't have done it as early as we did. So I guess the lesson that I learned from that is, if you think you have a beta prototype, it's actually an alpha prototype. Your first run is actually a beta prototype, and then maybe your second run is like the real deal. Maybe. You guys, I'm like preaching to the choir here, but so yeah, no, just like wait until a little bit later maybe for that. Keep people close. Go ahead. Yeah. I feel like this is probably the biggest single one. Platforms, at least the way we built it, this sounds terrible. This is not an investor pitch. Platforms do not solve problems. They just don't solve problems, right? Like if you go to an investor, they want to know what population X, but 100 million people have cars, and when people get into cars, some of them scratch their legs against the steering wheel. It's a pain point, and I have an anti-steering wheel scratch device. You know, you're kind of like, it's like so obvious, and there's a pain point, and you're solving it, right? It's just not the way platforms work. It's just not. And so, like, I guess my comparison is, you come up to a guy in a boat, in a leaky boat, and you're in a big boat that's not leaking, and you look down and you say, hey, what do you need? And he goes, I need a bigger bucket, right? And you're like, maybe you should just hop in this bigger boat. And that's what I feel like we make the argument to our users. It's like, you don't need a bigger bucket. Like, they're writing stuff with pencils. They need pencils with bigger erasers. It's like, no. You know, but, so, again, if you guys are designers, you know all this stuff. I just feel like it's particularly applicable to platform development. CEOs are fine. I'm sure there's a CEO or two in here, and that's totally fine. But we didn't have one, and so it costs a lot to get one. And so I guess the point is, you can be successful with the assets that you have. Like, utilize the assets that you have. We didn't have that asset. We couldn't utilize it. It would have been immensely expensive and sort of got us to try to do that. And so we kind of managed to do it without that. Probably at some point we'll need to do that. But yeah, that's just a lesson, I guess. So where are we now? So that was, we started, like I said, 3.5 years ago. We've been beta testing this thing, which is what we built. We actually built 200 of these by hand. We bought our own pick and place machine, placed 160 odd parts on a $15,000 Model in the basement. We ship these all over the world, including Africa, South America, Asia. We collected almost 320,000 measurements. Now, mind you, this is not a temperature sensor, you know, you stuck on a building and it measures automatically once every 5 seconds. This is a human being in a field clamping a leaf 320,000 times in 15 different countries. So there's a lot of people involved. And it took a lot of good data. Throughout that process, we've had about $1.5 million invested through MSU and various partners like the McKnight Foundation and USAID and others. People have created 400 and 1,400 projects. We have almost 200 members. And like I said, we should have about 200 places. So now we're at the end of the beta. But the end of the beta is where Barry stepped in and took the ragtag crew to make something that people might like. people are like, what is this thing?
Yeah.
And inevitably they flip it around and they do it the wrong way, like every time. So,
Yeah.
very solid wrong. So,
Well, yeah, well, all right, cool.
you want me to press the buttons?
No, I think I actually feel like I'm comfortable with it now.
Okay.
All right. So Act 2 is the design collaboration of Greg and his group and me. So I got a little lucky. I knew Greg was going to call me. And my daughter was moving into Michigan State. So instead of him calling me, I called him and said, hey, I'm coming to Michigan State on this day, so happens to be, a good day for me. You want to meet and start talking about this sooner than later? And luckily, he said yes. So, was able to get together and have this conversation around a design brief. So that's where things start for me. I don't want you to feel like you got to read all that stuff. Okay, it's really about understanding that he's got a problem to solve. He's got criteria he wants to give me to design around, and I'm going to use that as a starting point for the process of being able to create what he's hoping I'm going to create. So, and at that point, I give him a proposal based upon my design process. Now, industrial designers always have processes of some sort. I've got a 4-step thing I use, and it's loose, but it usually works really, really well if I can convince the customer to utilize the process. So if I can get Graves to believe that I need to do some research, which some people don't want to do, then I'm going to have a better handle of where to go when I start doing concept work. So this is the product, and this is the kind of grand picture. The research of it is the springboard that gets added to the criteria he gave me to be able to do concept work. And it's going to be this device. It's going to be a handheld. It needs to be probably screwed together. It has to be a minimal amount of parts. It has to have all this junk inside, and it's got to work. So that's where I jump in after the research, and we review the research, and research tells us some things, and we add those criteria to me doing some concept work. And so we're talking about hand sketching. I still hand sketch. I love that. Prismacolor black pencils and paper. I get a lot more ideas out quickly that way, and I just love the smell and the feel of it. And so I'll do almost any project, and I'll sketch first. But that always leads to something else. And for that matter, the traditional versus the much more modern way of looking at things, I go back and forth on. So going from a sketch to a 3D model and back and forth is what I usually do. At one point or another, we have a review and we decide what we're going to work on. This is the favorite shape and form, and here's the features we like. From that, we'll have a refinement phase. Usually it's one idea. Sometimes the customer wants 2 or 3, and that's okay. But if we can narrow down to maybe a mix mash of the best thoughts from the concept phase, we will then be able to create 3D forms. And in the case, we built this guy right here, and that gave us a lot of information that was really valuable at the moment we had it. And they didn't know it was even coming. I just had it made. So from that, if I'm doing 3D, I hand off that 3D because I have a seat of alias, which is where I do my 3D in, and I hand that off to whoever's working in the CAD side of things, and they are able to use that as a basis for doing the finalization. So I don't do CAD. I don't do B-side stuff. It's not my thing. It's not what I do. There are better people for that. So hand that off to Greg, and he did the final models yourself personally, right? And then kicked off some prototypes, and we're in the tools, right?
Yep, 2 weeks, 4 weeks.
Yeah, cool. So to be specific about some of the things that we're talking about here, and going through the phases on the research side of things, I asked for information from them too. So that's that chart before. It's one of those charts. And it tells me a story about the usage of the product. And so users being what they are, what is it that they're going to be doing with this thing? And who are they? So, scientists, individuals, people working in nurseries, going from maybe taking 2 or 3, readings versus a couple hundred readings. That is a great range, and one of the criteria we've got to work to. So, and then I look at competitive sets. And the cool thing about this is I always end up surprising the customer with something they haven't seen before. And that's the beauty of the internet now. There's always something new every stinking day. So the situation is I always end up giving them something they never saw before, and that's fun. I enjoy that. What also doing a competitive set does is it identifies what the price points are of those products, what their features are, and usually what not to do. I can tell you right now there's a bunch of crap up here. So I'm looking at stuff that looks like it was designed in 1980, probably was. And those are the things we don't want to do. And there's also probably some intellectual property that's out there that we have to identify as stuff we have to dance around. Possibly, don't know. But long and short of this is more of a tale of what not to do. I'll look at related areas of design. So handheld measuring devices, devices that are used like what they're doing in terms of they're reading something in either plant life or soil. And what are they doing? So, this eating thing, the little yellow guy on the lower right, that's a cool looking design. It's very simple. And it's, it's just a cool design. That one and the flower pot Y-shaped thing I saw at CES 4 years ago, 4 or 5 years ago. And I thought those were cool stuff. And so that's not exactly I'm going to design around looking like that. But those are parameters of what the field is looking like. And then I look at design inspiration. So handheld devices that are unrelated. And what do they look like? And how do they feel? And what are they doing with color? And what are they doing with textures? And so those are really great ways to inspire where I'm going to go. And then design details. We talked at length about how it's going to go together. Where screws going to be part of it, and if we're going to have screws, are they going to be celebrated? Are they going to hide them? How are we going to do? If you're doing 200-300 measurements in a day, a lanyard's probably a good idea to have it on your wrist. You might drop it. You don't want to drop it, so lanyard's another good reason to have. You don't want it to get super wet, even though it's somewhat watertight, right? So rubber grommets are also part of it. Well, we decided it wasn't going to be.
It's not waterproof.
Waterproof.
That's for sure.
Right. Yeah, that'll be the next one. Right. Yeah, okay. So all that rolled up into some directions to take. The research findings combined with the criteria that I got leads to here's what we're going to do. So, and there it is, the start of what was given to me. This is the brick block design that they had. That is a great proof of concept. They made 200 of them. They got good data from it, within reason. For example, the mechanism for clamping down was a bite down kind of thing, okay? It wasn't what we ended up at, but that showed to be something that needed to be refined. Exposed wiring is obviously not a good thing either. So, going from 2 blocks, glued and screwed together, it's going to be, I hate to say it, and I think I even said it in front of you, that's going to be easy to beat, in terms of shape and form. They had refined it to this shape in terms of the CAD. Again, more block stuff, but it was much more in the direction they were going to go with all the boards and the battery size and what electrical was going to go into this thing and how it was going to even clamp now. They decided to move towards a straight-on clamp for 2 reasons. One, and again, correct me if I'm wrong, gets better readings. And then 2, because it is open and shut straight up and down, they could clamp down on a cuvette, which is a holder of liquid. And that cuvette allowed them to take readings for like algae, right? So that data was given to me, and I used that as a basis for some of the work that I did. So here's the hand sketch stuff. And that's all based upon that data right there. So when I start sketching, I try to be realistic about this. I'm not going to be pie in the sky. I'm going to use the data I got as a basis for good design so that I can get farther down the road quicker if these sketches are within reason of the envelope that I've been given to work in. So I think we kind of like this one, that's why I grew that one the best. But there's other aspects in here that brings us to a kind of a semi-refinement phase that again was 2D, but again was also based upon the data. And so they got greedy, they wanted about 4 or 5 ideas, not just one, kind of semi-refined in this case, still under the concept phase aspect of this. But this is much, much closer to the real design, to the point where we could really feel comfortable that this was where we're going to go. This product's going to be real. And so we jump into refinement. And that's where this guy was made. And I brought this along at one of our reviews, and they didn't know it was coming. So I pop it out, they got all excited about it, and they go, okay, wow, this is interesting. Yeah, okay. So the guy with the biggest hand, yeah, this feels good. And the gal with the smallest hand, it's feeling a little thick. Okay, well, good, we'll put it on a weight loss program. That's one of the things. And then there was, details that are missing here. So inside is not, there's no inset for the grabbing part of it. But also, what they did was, they said, what is this going to feel like with the battery in it? Because it might be, the battery's going to be at the back end. What are we going to do if that feels funny, if it's oddly balanced? Oh, I don't know, you want to put one in there? And they go, yeah. So they went back in the back and they drilled a hole right there and then while we're still talking. And they slipped a battery in there, and that allowed us to immediately figure out that this thing felt pretty good. And there was more stuff going in the front end of it, so the balance was going to be all right. We were feeling, just having this little study model made a huge difference on the direction we took. So here's the slim version. Took a diet, and what's good about that is it combines a couple of 3 things from all the sketches that I was doing. We were able to keep the part line the way I wanted it and have it work with where the grommet was going to sit. We had some thoughts about how the lanyard was going to be built into it, and there's a variation of that coming along. But where the button was going to be and how tall it was going to be and all the actuation part of it was all really figured out at this point. So this is data that I gave him. And also like getting the logo from you and immediately put it on somewhere. Branding the thing is always a good thing, So I then did some color study work, and that again led to, well, what are we going to do with this thing when we eventually get around to building it? And I think that it's pretty much staying in the white zone. Then the finalization phase, which is more or less me turning over my work to Greg, and Greg, I think there was changes in the boards and some changes elsewhere. The switch, the button on top had to be done a little differently. So those things got done by him and not by me at that point. And so be it. I can be only afforded so long before they have to cut me loose. So, but long and short of it is the overall design is still pretty dang close to the illustrations and the 3D renderings that I had done. And so there's your second data test, if I'm not mistaken, model, because you guys got a 3D printer, they built some models off of that, and that is now the point where he kills me off and moves on to the rest of the story. So
Go back to
go back to this one.
Yeah.
All right. To that. Yeah.
So just to I know I'm on this, I'm sorry, but just to clarify, if you look at, there's a lot to this design. And I should have brought one, but there's actually 6 different molded pieces in here. 1, 2, 3, 4, 5. Well, I guess it's just 5. And then there's 2 rubber molded pieces. There's 2 pieces here, 1 piece here. There's 2 light guides, so you've got light going out and signal coming back that have to get managed with mirrors on 2 locations on each light guide. There's a power sensor which has 3 components which have to be exactly aligned. There's a spring that sits here on 2 dowels, and so that has to get put right into the mold so that everything lines up correctly. It gets used out in the field, so dirt on gets on the dowels. I mean, it's like a complex little design, and really good job of taking pretty specific design limitations that we provided and then give feedback on that. So yeah, it's not just always get brought up.
Right. I wasn't going to go there.
Yeah.
I was going to let you see what you wanted to say about it.
Yeah. So anyway, it's complicated.
Yeah.
So, right, the rest of the story, so yeah, like 10 minutes. So we do have this final device now, which is all put together. The beta really helped us immensely to understand the science and the application of the photosynthesis measurements and some other things. And then we spent an immense amount of time calibrating. So each of these individually has to get calibrated. We have about 15 minutes of calibration that goes in each device before it gets shipped. Because, as you know, 10K resistor is not a 10K resistor. And if you've got a complex little part, all this gradations add up. So we spent a lot of time doing that, making the case, making sure everything lined up, making sure that we had the parts in order, that we can get them in on time. That whole process was just taken a really long time, and we've been delayed. We were originally supposed to ship in April, like no surprise, but like every Kickstarter project in the world except for not a Kickstarter, we still haven't shipped yet. But we have sort of our final numbers, so we should be able to ship within 6 weeks. So, not to brag, but it really is like a $600 device competing against $50,000 devices. And I challenge you to challenge me on that. We really made something unique. And the reason is we believe this device can be sold to tens and ultimately hundreds of thousands of people. And the people who make stuff like this now believe it can be sold to hundreds or thousands. And therefore, when they're paying off their development costs, they need a $50,000 return to make that work. And that's the fundamental difference. And as you know, when you get these markets that have been around for a long time, like some of these have been around for 30 years, they have a very specific and limited perspective on their market and what it is and how big it is and what they can do. So I think in that way we're doing something different. Go ahead.
Oh, I'm sorry.
Just a check. Yeah, and it is all free and open source. So the hardware, the software, the data, the hardware and software is all open source. The data is as open as it can be. And we intend to continue that as we go. So yeah, there you go. So I guess the lessons from this last sort of section of our development is if you have a new playbook, which we kind of had a unique playbook, fully open technology, meaning open software, open hardware, and open data, is potentially a great business strategy. But the playbook's a little hard to read. So if you've never seen this is from the Codex Seraphinianus. It's really clever. It's this Italian guy who made an entire 500-page book that looks basically like this. Like it should be interpretable, but it's not. So you just go from each page, you're like kind of like, what? Anyway, that's kind of what I feel like we've been doing for the last 3 years is figuring it out. And it's not easy, but I really do believe that there are ways to make this successful. And if you want to talk like business model discussions after this about how that works and what our plans are and how we think we can generate revenue and be successful, I'd be happy to do that. And then, yeah, that's like a given. You've been listening to me the last 20 minutes. But really the only way to understand that and to understand that playbook is to go out and try to figure it out yourself. I think every single individual experience and business development is different, and especially when you're trying to do something different than everybody else, you just have to learn as you go. So, yeah, that's it.
Questions for Barry and Greg?
Sure. First of all, that was awesome. Like front to back, what a great presentation, cool product, great story, right? So thanks. Yeah, I'll start with that. But a lot of people in this room are hardware people, right? I'm dying to know what's in this thing. What are you sensing, right? You mentioned waveguides, lighting them out. Like, what is this thing?
I'm sorry, I should have brought devices in. Like I told Barry, I just totally forgot. So I do have some boards of like a previous version which you guys can fool around, and they're like development boards with stuff tacked on. So we have there's a clamp. You can go back to yeah. Keep going. That one was particularly good. This one. So this is a clamp. So this is 2 dowels here, and it moves up and down. So you put the leaf right here, and there's a little light guide. There's a lot of stupid amount of design that went into this. There's LEDs right here on each of these light guides, and then the LEDs bounce off mirrors and go out and hit there's 5 LEDs on each side, so 10 LEDs total. And then there's a detector on each side that sits right here that whatever signal comes back, if it's absorbance, transmittance, fluorescence, hits those detectors. So there's an infrared detector, so that's 700 nanometers to 1150 nanometers on one side. And there's a visible light detector, so that's 400 to 350 to 700 on the other side. So what it allows us to do is it allows us to do any kind of absorbance, transmittance, reflectance, fluorescence on 8 different LEDs. So
those eight LEDs are different wavelengths.
Different
each,
wavelengths,
and so you got a
right.
sensor for also several wavelengths.
correct.
Is that just one pixel, or is it like
It's
a
just
an
one
array?
pixel.
Okay.
That's right. We actually, so we have a series of other devices that we're working on, like a soil spec and a coral spec that we actually take underwater and measure coral bleaching with. And the coral spec uses, if your hardware people, Hutzel just came out with like a fully integrated surface mount spec that has 6 nanometer resolution. Probably within 2 or 3 years it'll be down to 2 or 3 nanometer resolution. Right now it's, if you buy 50 or 100, it's like, 90 or 100 bucks a piece for a full surface mount spec. It's crazy. So there's pluses and minuses, right? In our particular case, we're trying to measure chlorophyll fluorescence, and there's a specific method to do that. We use pulse modulation, and so we're pulsing the lights, for 10 microseconds every 10 milliseconds.
Okay.
Pulse, 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 pulse. And that way we don't affect the plant, because if you turn a light on the plant, photosynthesis changes like within microseconds. So you don't really want to affect the plant. You just want to test it. So that's what we do. And that's one reason you pulse. And the other reason you pulse is if you're doing this outside in full sunlight, you are trying to measure the fluorescence response, which is in 680 to 700 nanometer range, except that the sun produces a lot of 680 to 700 nanometer. So using pulse modulation and then AC filtering, you can get rid of all of the background. So that makes the electronics, as you can see, like a little more complicated. We've got these pulsar circuits and control and everything. But the outcome is it's way more flexible. So that it's using those lights, the combination of those lights and detectors that we measure for photosynthesis, chlorophyll content, absorbance, that kind of stuff. So that's the electronics. And then, like you guys know, like once you make a board, then you throw all the standard sensors in. It's like, well, a temperature sensor, whatever.
A couple times.
Exactly.
Yeah,
So who cares at that point? It's like, I got a bus, put it on. So we did all that stuff.
So you got this big data set now. I'm just going to keep asking questions.
Go for it.
Right.
Procedural interruption here. Can you give us an update on the pizza, Christy?
Yeah, I need to go and carry it up. It is at the front door right
So
now.
we have about 5 minutes?
Can you give me 5 minutes to go and
So
help
we're
carry it
going
up?
to meet you downstairs?
And then
or-
we'll take the stairs to the 6th floor. I'll have some of the guys help escort you down the steps because the elevators need to pass.
Yep.
So we have about 5 minutes.
Give me 5 minutes to go down.
5 minutes.
All right, so now you've got this data set. Like, how big? Where does it park? How do you get access to it? What analysis tools are there?
Sure.
What's going on?
So it's on photosync.org. Part of I think another thing that I feel like we've learned is there's Internet of Things been around for a while. You can push data to 100 million, like a million different sites, but it's completely unorganized. I mean that's at least how I feel. And so what we did is we organized things around what people want to know. Is they want to ask and answer a question, right? So people will create a project with an intent. It's a question. Maybe it's again my simple like, what's the range of photosynthesis in bean plants or something? That's a question, right? So it has a specific method. They apply a specific protocol to it. And in fact, this device receives a JSON and then interprets that JSON. So you can tell it to do whatever you want. There's a whole API just for the device. You can have it just measure absorbance. You can have it do a 10-hour-long protocol where it measures all sorts of things and turn lights on all you want. There's a whole protocol associated with that. So anyway, the projects is what contain the data. So you go on our website, you look at different projects. You could download the data as a CSV, or you could look at it through our data explorer and then analyze it that way.
So you provide some sort of analysis tools just online, but I can grab a data set
Correct.
if I need to.
Yep.
All right, one last question. I promise I'm done here. What's a surprising outcome that you ran into? You got anything that you just said, holy shit, didn't see this one coming? Well, with the data set, I had the design process. I'm sure had thousands of those. With the data set, like anything unexpected.
Yeah, I think that it's a little technical, but the efficiency. So how much of the incoming light into photosystem 2 goes on to do photochemistry, meaning goes on to make sugar. So normally it's, in the dark it's like 80%, and in full light it's like 10%. And I'm not saying it's not like plants are not 80% efficient. I'm just talking about that first stage. So people measure that for a long time. But you can also measure, and we came up with a clever short method for measuring other pathways, right? Because light comes in, some of it goes to photosynthesis, some of it goes to other pathways. And plants spend an immense amount of time regulating this incoming light. So one of these other pathways they call non-photochemical quenching. It's this sort of cycle between two different chemicals that dissipates energies. So we found that that particular cycle is really strongly associated with stress. And it's strongly associated with pest stress, strongly associated with pathogens, it's associated with drought. We were able to do prediction on, for example, a root rot before it became visible to the eye. So that's the first thing that we learned. It was like, wow, this is kind of cool. Except then as we got more projects, it became more complicated because it would respond in different ways to different things. And that's why we started using neural networks, because you can't, you can use traditional regression modeling, and it kind of tells you some things, but it's complicated to implement. Whereas a neural network, we can kind of just be like, take these 40 variables, right, and then just give me a prediction out. Now, as a scientist, I think it's frustrating, and we keep having these discussions. Scientists are very frustrated because they're like, well, what does it mean? And it's kind of like, I don't know, it just predicts it really well. Well, that's useless. I can't write a paper based on that. So, we're trying to, and people are doing this also, but trying to figure out how do you interpret what these neural networks are identifying. But that's kind of where we're moving, because it's generalizable and it's cool. Now there's so many libraries for so many different languages that you can implement a neural network. There's even one for JavaScript. So the problem with me training all your data is it costs me a lot of Amazon time, right?
Yeah.
That's really expensive. But if you're downloading your little CSV of 10,000 data points and you want to train it, we can implement this JavaScript neural network, and you can do it client side. So you train your own data. We don't have to pay your side, right? And then the output is just a JavaScript function. It's not. You don't even have to have the library to implement the function, right? So you take that JavaScript function and you chuck it back in, and now all of a sudden the next 1,000 that they measure utilize the training from the first 1,000, right? So that's what we're moving to now, and that's really the completed circle. And we had this idea 3 years ago, but it was I don't know how we're going to do this. And then we just sort of got part of the way there, and then all of a sudden, the things are appearing to allow us to complete the circle and really have someone do the research, build the model, and then apply the model all in the same project, all on the same platform. And then allow people to use that data.
And that is why I brought him.
So my personal neural network is now predicting that the pizza is ready.
Ready.